Hello, welcome to this lesson. In this video, we are going to learn about power in AC circuits. So there are three kinds of power in AC circuits. We have the apparent power, the active power, and then the reactive power. The apparent power, okay, and then this is normally represented with the letter S, okay, and then it is measured in volt amperes, which is usually represented with VA. And then we have the active power, which is also called the true power. We have the active power P, and then this is measured in watts. Then it is uh, yes, it is measured in watts. Okay, and then it is represented with P. And then we have the reactive power. The reactive power, which is represented with Q, and then it is measured in volt amperes reactive. Volt amperes reactive. Into brackets symbolized as VAR. So these are the three kinds of power that we have in AC circuits. Okay, the apparent power is the total power in the circuit, and then the active power is the power consumed by resistive elements. Okay, and then the reactive power is the power consumed by the reactive element. So I have these two figures here. The first figure here shows the phase diagram for the various power that we have in AC circuit, and then the second one shows the phase diagram for the circuit element, that's the inductor, capacitor, and then the resistor. So this Z here is for impedance. So what this circuit actually is actually telling us is that the reactive power is normally consumed by the inductor, okay, element in the circuit, and then the active power or the true power is consumed by the resistor in the circuit. Okay, so these two will match, and then um, these two will also match, and then the apparent power will correspond to the impedance, okay, which is representing the total power in the circuit. Okay, so for the apparent power, that will be corresponding to the impedance, okay, and then for the capacitor, okay, it doesn't consume the reactive power, okay, it rather reduces the consumption of the reactive power. So that's what the capacitor does. Okay, so that's what these two figures were actually representing. So now let's look at what we're going to do next. Okay, so for the apparent power, like I said earlier on, this is the total power in the circuit. Okay, so you have the apparent power S to be equal to the product of the total voltage in the circuit times the total current in the circuit. Okay, so this is the expression for the apparent power. Okay, and then from the phasor diagram that we have here, okay, we can see that cosine of phi, okay, will be equal to the adjacent side over the hypotenuse, right? So that would be P over S, which is the active power over the apparent power. Okay, so from here you can see that the active power P will be equal to S cosine of what? Phi. Okay, that's for the active power. And then we can see that for the reactive power also, we're going to have the sine of phi, which is equal to the opposite, which is the reactive power over the hypotenuse. And then we are going to get the reactive power to be equal to the apparent power times the sine of what? Phi. Okay. So we have these two here. Okay. So from the Phasor diagram, we can see that the square root of the apparent power should be equal to the square root of the active power plus that of the reactive power. Okay, and then we've already generated the expressions for the active power and then the reactive power. Okay, so from here back to the active power, we can see that the active power will be equal to the total voltage times the current. So we have VI multiplying the cosine of phi. Okay, and then similarly, you can have the reactive power to be equal to VI multiplying the sine of phi. Okay, so this is what we are going to have. Then let's go back to this cosine of phi. The cosine of phi is actually termed as the power factor, which is usually represented with PF. Okay, so you can see that uh, from this expression, okay, you can see that the power factor, which is cosine of phi or PF, will be equal to the active power, okay, over the apparent power. So anytime you're asked to find the power factor, that will be the active power over the apparent power. Okay, so normally the power factor is said to be leading or lagging. Okay, so in some cases you may hear that the power factor is leading, and then in some cases you may hear that the power factor is lagging. So when you hear that the power factor is lagging, then that means the current is lagging the voltage in the circuit. And then when you hear that the power factor is leading, that means the current in the circuit is leading the voltage. So let's take note of this.